In today's notes, we're going to look at function notation compositions. So in function notation composition, you definitely want to know how to do basic function notation. So there was more than likely a video that was over this last night, so make sure that you actually watch that video. If not, you should have a good understanding of function notation from Algebra 1. So function notation composition is where you're pretty much taking two functions, so usually an f of x function and a g of x function, and you're combining it. When you combine it, it's going to look like this: f composed with g of x. I will make a note. This is an open circle, so this is your composition symbol. That is completely different from f times g of x. In your video notes from last night, you should have watched this and you should have seen that that little dot, so notice that that dot is not an open circle, that represents multiplication. So that's when you're actually multiplying the two functions of x. With function composition, you're doing something a little different. You're actually going to plug one function into another. Same thing if you had the function composition of g of f of x, which is this guy here, g of f of x. When you have g of f of x, you're going to combine it to look just like this: g parentheses f parentheses x. And for the top one up here, this is f composed with g of x. So whenever you're pretty much rewriting it in its composition form, you're literally taking one function. So in this case, you're taking g of x and you're substituting it into the f function. Similarly, if you're looking at this function down here, you're taking the f of x function and you're plugging it into the g function. So let's go ahead and look at a couple of examples to see exactly what we're supposed to do. So in example number 1, we're going to find f composed with g of x. First thing I'm going to do is rewrite this as f of g of x. Okay, well, now that I have it written out, I'm going to work from the inside out. You're going to hear me saying that a lot. Work from the inside out. Okay, so inside we have g of x. Okay, so g of x is represented by this function. So I'm going to rewrite this as f of g of x, which is x minus 1. Every time that you plug these things in, take a quick minute and just look at it. Is there anything that I can do to potentially simplify it? Okay, well, as of right now with this x minus 1, no, there's nothing you can do to simplify. So now that we've done that, we're now going to take the x minus 1 and substitute it for the f function. The f function is right here. So we're going to take x cubed plus 8, and we're going to substitute in what's now in parentheses. Well, what's now in parentheses is the x minus 1. So I'm going to substitute in x minus 1. This is what we need to solve. So unfortunately, I can't let you leave it like this because the cubed means that you need to multiply this guy 3 times. So over here to the side, I'm literally just going to the side of my paper. I'm going to do x minus 1 times x minus 1 times x minus 1. I need to multiply that out 3 times. So let me focus on the first two. I'm going to FOIL. X times x is x squared. X times negative 1 is negative x. Negative 1 times x again is negative x. And negative x times negative x is positive 1. I know I have to multiply by this in just a second, but I won't right now. Let me combine my like terms. So x squared minus 2x plus 1 is now going to be multiplied by x minus 1. All of this work that I'm doing to the side, take your time to actually work through it. It will make your life a lot easier when you're trying to simplify this. Okay, so now we're going to distribute. X squared times x is going to give me x to the third power. X squared times 1 is negative x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is positive 2x. 1 times x is positive x, and 1 times negative 1 is negative 1. Make sure you look through all of my signs and look through all of your signs to make sure that your numbers and answers look like mine. From here, I'm going to combine my like terms. So, okay, I only have an x cubed, 1x cubed. The x squareds I can combine. So negative x minus 2 is negative 3x squared. Don't combine the exponents, leave it as a 2. Now I'm going to combine my x's, which will give me positive 3x. And lastly, I'll combine my 1. Well, there's nothing to combine with 1, so I'll just leave it as 1. All of this is what this was simplifying to. So when you FOIL x minus 1 to the third power, you're going to get this expression here. So what I'm going to do right now is I'm going to replace all of that x minus 1 cubed with x cubed minus 3x squared plus 3x minus 1. Please don't forget about this 8, that positive 8 at the very end. Don't forget about it. So I'm going to add 8 to the very end. Now that I have this written out, I'm going to simplify one last time. Okay, well, the x cubed again is the only x cubed. There's only one 3x squared. There's only one 3x. There is, however, a negative 1 and a positive 8. So these two I have to combine. Negative 1 plus 8 is positive 7. This is my answer. On your tests and quizzes, make sure that you not only simplify something that's being cubed, or this could be squared, whichever. Make sure you actually multiply that out. And then also make sure that you write your answer in descending order. So notice that the highest exponent is a 3, and then it goes down to 2, then 1, and then your constant, which is 7. So please make sure that you actually write it in its descending or standard form. Okay, let's look at another question. Let's look at number 2. This one says h composed with g of x. Okay, well, we didn't see it above because we only saw f and g, but you're still going to do the same thing that we did for the last question. So the first thing I'm going to do is I'm going to rewrite this as h of g of x, just like this. It doesn't matter what the variables are for your two functions. You're still going to write it with the one that's closest to x here inside of the parentheses, so the innermost, and then whatever's outside, whatever function is here, you're going to put that outside. Now we're going to do the same thing and we're just going to simplify. So again, we're going to work from the inside out. So the inside function is g, which is x minus 1. Take a quick second and look at it. Is there anything I could possibly do to simplify it? No. I'm now going to take the h function, which is 5x minus 3. And inside that innermost parentheses, you're no longer using the x, you're now using x minus 1, which is the g of x function. So we're going to write this in as x minus 1. From here, we're just going to simplify. Don't leave your answer like this. You can easily distribute. Y'all love to distribute, so distribute. Don't forget that negative 3. And then the last thing we have to do is combine our like terms. That's your answer. Notice that for the first two questions that we just did, we had an x inside of the parentheses. So for both of these, we had an x inside your parentheses. For the next two questions, we might not be so lucky. So let's look at example 3. In example 3, I'm going to still be using these functions up here at the top of the page, so please pay close attention. So for g composed with h of 2, I'm now going to rewrite this as g of h of 2. And I'm going to, again, work from the inside out. So I'm going to have g parentheses. Okay, well, h of 2, I actually need to simplify. So the h function is 5x minus 3. Instead of rewriting x, though, I'm now going to substitute in a 2. Okay, like I said before, just take a quick second and look at it. Is there anything I can do to simplify? Okay, well, this is actually nice because unlike the last question, I wasn't able to actually combine anything in the parentheses. But now that I have it written like this, 5 times 2 minus 3, I can actually simplify that. So we're going to rewrite this as g parentheses 10 minus 3. And 10 minus 3 is going to give me 7. So my last step, I've already simplified the h of 2. Now I need to find g of 7. So keep in mind, you're only focusing on what you've simplified so far. So for g of 7, I'm going to use the g function, which is x minus 1. And instead of putting in x, and instead of putting in 2, we've already simplified 2. 2 gave us 7. So we're going to substitute that in here. Always keep your work organized because it'll help you stay focused on what you're solving for. 7 minus 1 is 6. I want to make this note before you try question number 4. Whenever you have a variable inside of your parentheses like we had for numbers 1 and 2, your answer will always have variables in the answer. So I'll say that again. Whenever you have variables inside your parentheses, your answer should always have variables. Sometimes you might get extremely lucky and your variables might cancel, but it's very rarely that will happen. Whenever you have numbers in your parentheses, so when you're substituting in some kind of number, you should always get a number as your answer. So with that said, I want you to pause the video right now and try example 4. You have a number in your parentheses. You should get a number for your answer. So for question number 6, first thing we need to do is rewrite this, h of f of negative 6. Again, we are going to work from the inside out. So h parentheses, we're going to do the f function, which is x cubed plus 8. Remember, we're not using x in the parentheses. We're now going to substitute in negative 6. So h will equal, or h will be outside of your parentheses. Inside the parentheses, we're going to do negative 6 to the third power. Please don't tell me that negative 6 to the third power is 18. You're actually going to multiply negative 6 times negative 6 times negative 6. Negative 6 times negative 6 times negative 6 is 218. Oops, not 218. Let's try that again. Negative 216. Don't forget your negative symbol. And then when you combine both of these, negative 216 plus 8, you're going to get h parentheses negative 208. Am I done? No, we still need to figure out what h is. So we're now going to do h of this number. So h is the function 5 times x minus 3. Instead of putting in that parentheses, instead of putting in x, we're going to put negative 208. So we had to multiply that out. When you multiply negative times positive 2, let's try that again. When you multiply negative 208 times positive 5, you're going to get negative 1040 minus 3. And negative 1040 minus 3 is negative 1043. Again, when you have an answer that's in that parentheses at the very beginning as a regular number, your final answer is going to be just a number. So try to keep that in the back of your mind. When you substitute in a number for your variable instead of an actual x or expression, you should get a number for your answer. That strategy will definitely help you on tests and quizzes because as you substitute in variables, you should get expressions. As you substitute in numbers, you should get just numbers for your answer. As much as I would love to do questions 5 and 6, we're going to actually move on to the next page. Use these as extra practice when you're studying for your tests and quizzes. Let's look on the next page at question number 8. Like I said, I'd love to do every single question here, but it would honestly just be redundant after a while. So let's look at question number 8. Okay, for question number 8, this says f composed with f of x. So this is f of x. Whenever you have problems like this, these are actually really fun and really simple. The reason why is because you're just using only one function when you're doing the composition, just one. So again, to make it easy, let's work from the inside out. So on the innermost parentheses, we're going to use the f of x function, which is negative 9x minus 9. Okay, well, in this parentheses for x, you're just going to substitute in the x that you have. So I'm just going to rewrite this as negative 9x with a pin minus 9. Okay, just to look at it, nothing changes. If there was a number inside of this parentheses, I would have substituted a number here, but I don't have that. Okay, well, there's nothing I can do. Now we're going to do the f function again, but instead of putting in x, we're going to plug in all of this. So the f of x function is, be careful, negative 9x minus 9. Inside this innermost parentheses, we're going to substitute in negative 9x minus 9. And then just like we did on the last page, we're now going to simplify. That's all you're doing, guys. When you have a function that's composed with itself, you're literally going to keep plugging it back into the original equation that you have. So just keep plugging it back in. So we're going to make this negative 9 times negative 9 is 81x. Negative 9 times negative 9 again is positive 81. Don't forget that minus 9. And then my last step is to combine my like terms. So 81x plus 72. That's my answer. When you get questions that look like this, please don't be afraid. Just Follow the steps. Work from the inside out. Again, as much as I would love to do every single question on here, questions 9 and 10 look fun. How about this? I'll save number 9 for fun for you for later, and then I'll do number 10. I will help you for number 9. You're just doing the composition of three functions. So we're going to rewrite this as H composed with G composed with F of 2. That's what you're solving. So hopefully that takes a little stress off of your plate. Okay, let's go ahead and look at number 10. So for number 10, it already has its composition wrote out. Let's start from the inside out. And I'm actually going to rewrite this just a bit because I see this 4 here. I don't want to lose that 4 as I work through it. So we're going to rewrite this as F of 4 of H, as in horse, of A. There's methods to my madness. So like I've been saying all day, work from the inside out. Okay, well, we don't have an H of A, but we have an H of X. Think about it. If you're going to do H of A, what's your new variable instead of X? We're now going to have 5A instead of 5X. Okay, so we already substitute in the H. We've substituted that in. We now need to simplify. Okay, well, if we're working from the inside out, the 5A, nothing can change. However, with the 4 times 5A, we can change that. We can make that into 4 times 20A. Now that I've simplified that piece, now I'm going to do F of 20A. Okay, well, the F function is all the way to the left of my paper. That's at negative 2x plus 1. And remember, instead of putting in an x, we're going to put in 20a. This is what I'm simplifying. So negative 2 times 20 is going to give me negative 40a, and we're going to add 1 to that. I usually ask at this point, is there anything further that we can combine? Are you sure you can't combine the 1 with the negative 40? I think we've gotten past that point. That's an Algebra 1 question. But just keep that in mind. You cannot combine anything else on that page, or at least on this question. Okay, we're almost done. Let's go ahead and scroll down and look at questions 11 through 15. I'm going to do question 13 with you. I want you guys to do numbers 14 and 15 in just a second. For right now, though, let's look at question 13. Okay, so if you think back to what we've been doing, we've been taking numbers or variables from an equation and plugging them in. We don't have equations now. We now have a mapping, so this is a mapping, and we have a table. Okay, well, we're going to have to figure out what to do here. So for question 13, that's the first one I said I was going to do. We're going to rewrite this for the composition as f of g of 2. Normally, I would look at the g equation, substitute in my 2, and then once I get that answer, I would substitute that in for f. Okay, well, I don't have an equation here. I do, however, have a table, again, and a mapping. Okay, well, let's focus on g of 2. G of 2 has to come from this table. What is the value at g of 2? Well, this is your x value. When your x value is 2, your y value is 6. So from here, I'm going to rewrite this as f of g of 2 is just 6. Okay, well, now I need to find f of 6. Well, f of 6 is just going to come from the f equation, or the f function. So in the f function, when your f value is 6, we're going to go from 6 to negative 4. So the value here is negative 4. Before you do questions number 14 and 15, I want you to add in one thing that I forgot to add in for the f function. We're going to go from 5 to 10. So right now, pause the video, and I want you to try questions 14 and 15 right now. Hopefully y'all had some fun with this. So let's look at 14. So this is f of g of negative 4. So again, the inside variable, or inside number, this is for x. I need to really just find the y value. So when x is -4 in the G table, your Y value is 8. So we're going to make this f of 8. Okay, now looking in the F table, if you don't remember from Algebra 1, this is your X column, this is your Y column. So if you need to label that out, please do so. The X column is always the ends of your arrows. The Y column is always like the arrowheads for your column. Okay, so now looking in the F table, I'm going to look for f of 8. These are all my X's. I don't have an 8 here. Ugh. Okay, well, you didn't do anything wrong, but I need to ask you one question. Should I put 0 for my answer here? If something was going to be 0, guys, it would look just like this. There would literally be a space for 8, and it would go to 0. We don't have that. Well, I mean, honestly, if we put any other number, it's going to assume that it literally is going from that X value to whatever the number is that we're assuming it's going to be. If you do not have a number here that you're trying to find in your function, what we have for our answer is D, N, E. That means that this does not exist. Hopefully I spelled exist right, but it does not exist. That's your answer. So D, N, E does not exist. Only use, and I know somebody's not paying attention, only use does not exist, DNE, when you literally do not have a value in your table or whenever you have a value in your mapping that you cannot find the answer to. Do not put it for answers that you just don't know the answer to. The last one is number 15. Hopefully number 15, you were thanking me for adding in that last number for the mapping. We have f of 0. Okay, well at f of 0, we're going to start at 0. It's going to go to 5. That's perfect. So we're going to have f of 5. And then at f of 5, oh my goodness, thank you, Ms. Tapia, for putting it from 5 to 10, because now I have an answer. So down here, we're going to make our answer 10. That's our final answer. We're going to look at the last page of this, and we're going to do questions 16 through 20. Not all of them, but some of them. Let's look at questions 16 through 20. Okay, so let me kind of recap what we've done so far. We've looked at equations, we've found our values, and we've looked at mappings and tables. We found those values as well. What we're going to look at now are graphs, and we're going to try to find our function composition value. So for question number 16, the first thing we need to do is try to identify G composed with f of 2. So when I find G composed with f of 2, I'm going to write this as G of f of 2. And I need to look at my graph. Okay, so in my graph, I have f of 2 is working from the inside out. So we're going to start with f of 2. F function is this parabola opening up here. So looking at that parabola, when your x value is 2, what's your y value? This little point, that's 0. So we're going to rewrite this as G of 0. Okay, now let's look at the G function. The G function is this blue graph that's opening down. So at G of 0, what's your y? Well, when x is 0, your y value is 7. So your answer here is just positive 7. Let's look at number 17 as well. For number 17, this is going to be f composed with G of 0. So f of G of 0. Okay, again, we're going to start with the inside out. So G of 0 is the blue graph. So G of 0 we actually just found, which is positive 7. So f of 7. And then at f of 7, on my black or purple, whatever color that is, my other graph, the one that's opening up, positive 7 is right here. F of 7 is going to be positive 3. The last question I want to look at is number 20. So for question 20, think back to the function notation basic notes that I gave you guys last time. What does that subtracting mean? What that means is you have to rewrite this as, let's start with G. G of negative 2 minus f of negative 2. That's what you're solving. So look at your graph and try to identify your numbers. For G of negative 2, okay, well, negative 2 is over here. G of negative 2 is going to be right up here at 7. So we're going to have in the first plot, positive 7. And you can put it in using parentheses, it won't hurt. The next thing I need to do is find f of negative 2. This one I'm definitely going to plug in using parentheses. So f of negative 2, here's negative 2 again. On the f function, that's at positive 2. Okay, I always have you plug these in using parentheses because in case I was multiplying some number in front, or especially here if I had a negative times another negative, you would want to make sure that you change that sign. So you just want to do this just to make sure you don't have any other signs to change, or if you need anything to simplify, that you pay attention to it before you just start writing your answer. So I'm going to rewrite this as 7 minus 2, because really none of the parentheses are going to affect your answer. And 7 minus 2 is 5. All of the remaining questions that I've left in this packet are extra practice to help you study for your tests and quizzes.